and today we're going to be looking at the effects of temperature on the rate of enzyme controlled reactions. So we can see that from this graph, this is how the rate of reaction increases and then decreases as the temperature is increasing along this axis. So at first, as we're increasing the temperature, we're increasing the kinetic energy. And by increasing the kinetic energy, there's going to be more movement between particles. So that's going to increase the rate of collisions. But we can't just say collisions. We've got to say that they are successful collisions. And what we mean by successful is that there are more enzyme substrate complexes being formed. So that continues to increase until you reach the optimum temperature. So this point here, if we read off the top rate, and if this temperature here would be the optimum for that enzyme. So this is Vmax, so the rate cannot go above this rate of reaction. However, when we pass this point, if we keep on increasing the temperature past the optimum, we are then going to start increasing the kinetic energy to the extent that that extent of movement is going to break hydrogen bonds. So at this point, it might break ionic bonds as well. With more and more movement, we're going to see a decrease in the rate of reaction. It'll be quite rapid because there'll still be a slightly complementary shape, but as we keep increasing that temperature and increasing it, we're going to have more bonds breaking, and the tertiary structure of the enzyme is going to change. So the tertiary structure is changing, so then the active site will change shape, and it will change shape so that it is no longer complementary to the substrate. Make sure you say to the substrate, just so you be specific for the marking points. So the active site is no longer complementary to the substrate, and that is when we class it as being denatured at this point here, when there is no enzyme substrate complexes being formed at all, and the rate is there's no rate of reaction at all. Yeah. So that is irreversible at that point. Thank you for watching.